Okay, in this video we're going to do the section 5.1 and give you a little unit circle background. All right, so in section 6.4 we use this exact table to show you that there are 4 sets of angles, one in each quadrant, that share the same sine, cosine, and tan absolute decimal value. So that word absolute should be there in front of decimal. Because look, some of them are positive, some of them are negative, but they have the same absolute values. We also notice that in 2 instances, the values would be positive, and the other 2 instances, the values would be negative. So let's explore that a little bit. So here, if we take an angle of 37 degrees, I see the sine is positive in the first quadrant and in the second quadrant. The cosine is positive in the first quadrant and in the fourth quadrant, and tan is positive in the first and the third. Now, how are these angles different? So you have different angles, but are they really different angles? So let's think about this. If we're in quadrant 1 and we're going to open up this way and say that is 37 degrees, if we're in quadrant 2 and we come all the way across here, and here's my angle, that's going to be 180 minus 37, which is, guess what? 143. That's the theta we're talking about. That 37 is called a reference angle, and we're going to get to that later. Go down to quadrant 4. If you want to have an angle that is the same distance from the x-axis as is the one in quadrant 1, you're going to have to take 180 and add 37 to it, and that gives you the 217. In quadrant 4, to get that angle that's the same distance, which is 37 degrees south, you would have to take 360 and subtract 37 from that, getting 323. So that's where these values come from, and we'll talk about more of that going forward. What you want to pick up is that sine is positive in certain quadrants and negative in others, and that's true for cosine and tan as well. So we could have gone through the same exercise with an angle of 64 degrees, positive, 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 and positive. Okay, so let's take a step back, and we're going to use this little mnemonic, and it's all students take calculus. In the first quadrant, all 6 trig functions are positive. A stands for all. So look over here. Do you see how in this first quadrant everything is positive? If sine, cosine, and tan are positive, then that means when you flip them over and get what? Cosecant, secant, and cotan, they will also be positive. Okay, let's go to the second quadrant. Second quadrant is the students, and that has the same first letter as does sine. So in the second quadrant, sine, so look over here, sine, and who is sine's partner? Sine's partner, should be saying, is cosecant. These are both positive. And we saw that here, positive and positive sine values. Third quadrant, we have a T for take and a T for tangent. So in the third quadrant, look what we can say about tangent. Tangent is right here. Third quadrant, positive. Third quadrant, positive. So that means in the third quadrant, tangent and its buddy, cotan, positive. And in the fourth quadrant, come down here, fourth quadrant, cosine cosine are both positive, and the c in cosine goes with the c in calculus. So cosine and its friend, or reciprocal function secant, are both positive. Okay? So, other things we're going to talk about. A key foundation here is every angle between 0 and 360 can be placed in a standard position somewhere on this XY grid. And then the fact that we have coterminal angles, we can always subtract 60 degrees or add 360 to get them back on this circle, and we can figure out what quadrant they are in. So this is back to being right angle trig. So we're doing SOHCAHTOAs again. I'm going to draw in these right angles, and I would invite you to do the same so that you can see that's your right angle. Here is the theta, which is the central angle, and that's what we're talking about here. All right. So you can read a little bit here, but let's actually work this out. What you need to understand is that these are the y values and these are the x values. Y is positive here and y is negative here and here. X is positive first and fourth, x is negative second and third. Think about where you would plot the points if you wanted negative x values, and that'll help reinforce where you're going to get your negative x's and your positive x's. Okay, so these values here, these four values, are called terminal points. The terminal points have symmetry. Notice how you have the same absolute values in all four cases. But the signs, SIGNs, change from positive to negative. In the entire circle, there's always two places, two quadrants where x is positive, and two quadrants where x is negative. Same is true for y. Two quadrants where it's positive, two quadrants where it's negative. If I want to talk about the 6 trig functions, and I wrote cosecant, secant, and cotan already, let's see if we can work backwards and get sine. So sine of theta. Sine is opposite, which is y, over hypotenuse. So does that make sense? Why cosecant would be the flip of that. Cosine is adjacent, which would be x over hypotenuse. And here we go. Flip it over to get secant. And tan is opposite, which is going to be what? The y over adjacent, which is the x. And that makes sense that when you flip it over, you get x over y. Okay, so let's see what this says. Adjust appropriately based on your quadrant to determine whether x and y are positive or negative, and then apply those signs appropriately to the trig ratios. Okay, let me say that I want our focus to be on quadrant 2. So here's quadrant 1, quadrant 2. Tell me what would change in quadrant 2. So which angles would become, which things would become negative? So in quadrant 2, x is negative. So I'm going to highlight that my x would be negative, my x would be negative, x is negative, x is negative. That makes only sine positive in the second quadrant, which is what I know from all students take calculus. Okay, so let me get rid of those colors. And let me just get rid of the highlighting. Whoops, I'm going to have to put my values back in too. Okay, let me put my x's back in. Okay, let's move into quadrant 3. What's going to happen in quadrant 3? Well, both my x's and my y's will be positive. Excuse me, will be negative. So y is negative, x negative, both negative, 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 what's going to happen? Well, it looks to me like everything is negative except for tan, because a negative over a negative gives me a positive. So in the third quadrant, tan is positive because both x and y are negative, and that makes cotan positive as well. Okay, so let me undo those highlights. That works out better, doing it like this. Okay, and let's do one more. Quadrant 4. What is negative in quadrant 4? It looks like the y's are. So if I go back in now and I highlight my y's, I see that cosine has no y's. So cosine must be positive in the fourth quadrant, and that is true because that C of all students take calculus is in the fourth quadrant, telling me it's positive. Okay? So I'll get rid of my highlighters, but you see how we made that interpretation and made those changes depending on what quadrant I put us in. Okay, next change. What if we are not in just any old circle, but we're in a unit circle? A unit circle means that the radius is 1. So we're going to change all those radii, all those r's, into 1s, and let's see what happens. Sine becomes y over 1, or just y. Cosine becomes x over 1, or just x. Tan doesn't change. Cosecant becomes 1 over y. Secant becomes 1 over x. And cotan doesn't change. But if you're in a unit circle, do you see how tan can also be identified as y over x, which is sine over cosine? And that means cotan can be identified as x over y, which is cosine over sine. So a little connection between the tangent and the cotangent and the sines and cosines. Okay? So that's a good insight right there. So here again, I can get all 6 trig ratios, and the change I made was I made my r's 1. Okay, unit circle centered at 0, 0 and has a radius of 1. So what does that mean? It means our equation that we did back in January is this. Okay? So, and notice also, with a radius of 1, this distance is 1, so that terminal point is 1, 0. This distance is 1, that terminal point is 0, 1, negative 1, 0, and 0, negative 1. And because of symmetry, if I know that this point's on the unit circle, then I know that these are also. Okay, how do we find points in the unit circle? So it says find all points in the unit circle given that x is 1/2. So the first thing we're going to always do is write down your equation. X squared plus y squared equals 1. X is 1/2. Square it. Y is still unknown. 1/2 squared is 1/4. Plus y squared equals 1. Y squared is going to be 1 minus 1/4, which is 3/4. And that means y is, very carefully, you get two values, plus and minus, radical 3 over radical 4, which is 2. So, I now have my y values. I know my x's will also be positive and negative. I like putting everything in my quadrants like this. If my x is 1/2 in the first quadrant, my y is root 3 over 2. In the second quadrant, my x's are negative, so that's going to be negative 1/2 root 3 over 2. In the third quadrant, everything is negative. And in the fourth quadrant, only the y is negative, and there are my points on the unit circle, given that x is 1/2. Okay, next one. find y such that this coordinate pair is a point on the unit circle in quadrant 3. In quadrant 3, I know that both my x and my y are negative. So let's find the y value by using my equation. X squared plus y squared equals 1. X is negative 0.8 squared plus y squared equals 1. That's going to be, what, 0.64 plus y squared equals 1. Y squared equals 0.36. So therefore, y is going to be plus and minus 0.6. So that point on the unit circle, that x value was given as negative 0.8. I had to generate the y value. It is negative 0.6, and I have answered the question. Number 3 says find all points on the unit circle, given the y value is root 2 over 2. So, start again, unit circle, equation. I don't know my x, but I'm going to square my y. When I square that, it becomes 2 over 4, which is 1/2. So then x squared equals 1 minus 2 over 4, which is also 2 over 4, but I'm going to write it as 1/2 right here. So therefore, x equals plus and minus radical 1 over radical 2, which we need to rationalize. And look what I'm going to have. I'm going to have the exact same values for x as I do for y's. Okay, let's find all 4 points using symmetry. First quadrant, we have everything is positive. Second quadrant, the x is negative. Third quadrant, everything is negative. Fourth quadrant, what's going on there? My x is back to being positive, but my y is negative. Okay, got them all. Okay, find x such that x comma negative 0.6 is a point in the unit circle in quadrant 4. Quadrant 4, I have x is positive and y is negative. Okay, so I'm going to look for a positive x. So what do? I'm going to use my unit circle. Plus negative 0.6 squared equals 1. Whenever you square a negative, you get a positive. So that's x squared plus 0.36 equals 1. X squared is going to equal 1 minus 0.36, which is 0.64. So therefore, I get two values for x. It's plus and minus 0.8. But in this situation, they want me on in the fourth quadrant. So the x I need is going to be a positive 0.8. Okay, and my point is going to be this. That was the x that was needed. Okay, and let me just make sure, find y. Okay, so this over here was the y that was needed. And then I just put them back in the coordinate pair. Okay, next thing. Now they want us to verify that the points that they give us are on the unit circle. This is different than finding a missing one. Okay, so if this point is on the unit circle, so is it on the unit circle? Well, let's see. This is my x, this is my y. I'm still going to do x squared plus y squared. So negative root 3 over 2 quantity squared plus 1/2 squared. Does this equal 1? Well, that's going to be a 3 over 4 plus a 1 over 4. And yes, that equals 1. So I have found that they are all in the unit circle. So now let's find our values. In the first quadrant, everything is positive. Second quadrant, which is what they gave us, x is negative. Third quadrant, everything is negative. Fourth quadrant, y is negative, x is positive. There we have it. Okay, a couple more of these. Is this point on the unit circle? If so, use symmetry to figure out the other 3 points. That looks like it could be a point in the first quadrant. So let me not jump ahead here. Let me be consistent. X squared plus y squared equals 1 squared. Okay, 3/5 squared plus 4/5 squared. Does that equal 1? This is 9/24 plus 16/25. I think I said 24ths. Both 25ths. That does indeed equal 1 because 9 and 16 is 25, and 25 over 25 is 1. So let's get our remaining points. Here's the one they gave us in the first quadrant because everything is positive. Let's jump to the third quadrant where everything is negative. And then in the second quadrant, x is negative, y is positive. In the fourth quadrant, x is positive, y is negative. Okay, another one. X squared plus y squared equals 1 squared. Radical 7 over 4 squared plus negative 3/4 squared. Does that equal 1? And that's going to be 7 plus 9/16. Yes, that's 16/16. So it equals 1. So let's get our other points. The one they gave us this time was in the fourth quadrant, right? Because x is positive and y was negative. Everything's positive in the first quadrant. X is negative in the second quadrant. Everything's negative in the third quadrant. There we have them. Okay, so now we have this sketch. They want us to figure out the 6 trig values for theta. Okay, so this is my x and this is my y, right? So let's think about this, how we're going to set this up. And they're telling us that we are on what? We are on a unit circle. So if we're in a unit circle, then I know my x is negative 5/13. That makes sense. My y is positive 12/13. That makes sense. And what is my radius? It's 1. Okay, so we're going to write sine theta, cosine theta, and they're putting theta in the second quadrant, tan theta. Okay, sine is going to be what? Looking at sine from theta's perspective, it's going to be opposite over adjacent. So that's 12/13 over 1, which is just 12/13. Cosine is going to be adjacent over hypotenuse, which is just negative 5/13 over 1. So I can just leave it as negative 5/13. Now tan, what's tan going to be? Well, tan's going to be opposite, which is 12 over 13 divided by opposite over adjacent, right? So that's going to be divided by negative 5/13. What happens when we divide fractions? We multiply by the reciprocal. The 13s cancel, and we end up getting negative 12 over 5. Now, is this making sense? I'm in the second quadrant. Second quadrant, only sign is positive. Am I getting that? Yes, I am. Okay, let's flip these things over and get our reciprocal functions. So, sine goes with cosecant. Flipping it over, I get that to be 13 over 12. Cosine goes with secant. Flipping that over, I get negative 13 over 5. Now, look what I did. I put the negative up top. You are normally going to see negatives up top, not in the bottom. Okay, so I'm just going to always put them towards the top. Even if they pertain to a value that would have been in the denominator, the math convention is to put it up top. And the last one is cotan. Take your last answer and flip that over, but keep the negative up top, and we have everything. And once again, I see that my cosecant is also the only one that's positive, and that makes sense because I am in the second quadrant, and in the second quadrant, due to what's our mnemonic, all students take calculus. In that quadrant, only sine and its partner cosecant are positive. Okay, now I want to give you a little introduction to building this bow tie diagram. Think back about special triangles. Special triangles are 30, 60, 90, right? If this is the unit circle, this is 1. Okay, how are these three sides related in a 30, 60, 90 triangle? The side across from the 90-degree angle is the 2A side. The side across from the 30 is the A, and the side across from the 60 is the A root 3. Using that, I find that my A has to equal 1/2, since 2A is 1. So this is going to be 1/2, and this is 1/2 radical 3, which is just root 3 over 2. So these are the values that I want. 1, 1/2, root 3 over 2. Let's switch this so that the 60-degree angle is here, the 30-degree angle is here. Here's your 90, here's your 1. Same values, so I'm just going to copy, and across from the 30 is the 1/2. Now we come to this other triangle, which you should recognize as the other special triangle, the 45, 45, 90. Okay, so what's happening there? Well, it's still in the unit circle, so the hypotenuse is still 1, and the hypotenuse equals A root 2. So what does A equal? If A root 2 equals 1, then A equals 1 over root 2, and you want to rationalize that. So that's going to give me root 2 over 2 for my A, and these sides are my A sides. So the values that I want to be using is the 1, the root 2 over 2, and the root 2 over 2. Okay, come over here. This is our unit circle. I can label the terminal points here because I know my radius is 1, so that's going to be 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Guess what's going to happen here? My x value, if this is going to be a 30, 60, 90, the x value is going to be what? So think about what your x value is. The x is on the bottom, so that's root 3 over 2, 1/2. If the next triangle is the blue one, which is 45, 45, so that means that this is 45. What are those values going to be? Well, that x is root 2 over 2, and the y is also root 2 over 2. Then we come to the green. This green is the 60-degree angle. So they're going to have the same values as the 30-degree angle, but I'm going to switch them because I switched the orientation of my right triangle, and there is the beginning of building unit circle values. Okay, so I'm going to stop there, and I'm going to tell you that for homework, what we're going to do is I'd like you to read 5.1 in your textbook, up to, so this is up to example number 4. And then on page 415 to 416, you're going to do numbers 5 to 21 odd. This will match exactly the material covered in these notes. So you should be okay doing that. Okay? Thank you for listening.